Hi, I'm Ryan. Today we're going to do a little experiment. Recently I saw a video that brought up the question of how many times can you fold a piece of paper? Well, you see, a piece of paper, no matter how thin it is, how small it is, can only be folded a certain amount of times because of the amount of mass that that piece of paper has and the amount of space that it takes up. This is going to be difficult for me to do with one hand, but what we're going to see today is that there is a finite amount, no matter how big the piece of paper is, that piece of paper can be folded. You see, the science behind that is every time you fold something in half, it doubles in size. So let's say like a Post-it note. One Post-it note, tiny little piece of paper, very thin. This can only be folded a certain amount of times because of its mass and its size, and we're going to double it each time. So as you see how thin it is, as I place it down on the counter, and I'm doing this with one hand, so it's going to be a little difficult to shoot and fold at the same time. One fold, and now it's already twice the size it was before the fold. I'm going to fold it again. That's two folds. Now it's twice the size it was before. As you can see, every fold gets exponentially bigger. If I were to keep folding this over and over and over again, I could get 40, 50 folds, 60 folds. So 60 folds would probably be about as tall as the Empire State Building. But this little piece of paper doesn't have the mass to be able to get to the point of the size of the Empire State Building. Now, if I had a piece of paper that weighed the same as the Empire State Building, I could fold it another time. This would be the third fold. And as you can see, it's 3 times thicker. This would be the fourth fold. And as you can see, 4 times thicker. And because this is so small and I've got big fingers, but the fifth fold, that's a tough one. And it'll stay in its fold. But the mass now is exceeding the amount of folds that I'm able to give it, because as you can see, the mass doesn't want to fold a 6th time very well, but it will. The 6th fold. Now, the chances of me being able to fold this a 7th time, even with a mechanical structure, are very, very low. As you can see, if I leave it on its own, it doesn't even want to keep the 5th fold, or the 6th fold. It tries as hard as it can, but it doesn't want to keep it. But as you can see, I took a tiny little piece of this, and now look at how thick I made it. Now I want to show you now we'll take a paper towel. Paper towel is much bigger than this little piece of paper, and it's just as thin and flimsy. So we'll fold it in half once. Oh, that's one fold. We'll fold it in half twice. Now, as you can see, it's already 4 times its thickness. Fold it in half a 3rd time. now it's 4 times its thickness. And then again. Six times its thickness. Well, no. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 times its thickness. Do it again. Hit fold. And then finally, the 6th fold. And as you can see, that's the mass. And that's as many times as you're going to be able to fold it. You're not going to be able to fold it again. That's as many times as you can multiply that mass. So as you can see, it doesn't matter the size of the piece of paper. It matters the mass, the weight of the piece of paper. So if you wanted to fold a piece of paper to be the size of the Empire State Building, you would need a piece of paper that had the same mass and weight as the Empire State Building. And then you would have to you could only fold it 6 times. Thanks for watching.